Hey, welcome back. This is the second video of the OpenGL tutorial on the Raspberry Pi 4, OpenGL 2.1, GLSL 1.2. And today we're going to be doing a very quick video. This is going to be the reshape function hook for GLUT. What this does is if you change the window size of your OpenGL context, it will make all your shapes correct. They'll stay the same size and same aspect ratio. Also, this is so if you have not a square window but a rectangle or a portrait window, everything will still be drawn correctly. This is what the reshape function does. It will update upon window reshaping. And let us get started. So let's do a new line here. GLUT. What is this? Reshape func. And we're going to need to put a function pointer in here. Let's do reshape. Okay. And then we're going to go up here and we are going to make a new function, void reshape. And this function takes two parameters. It takes in your width and it takes in your height as ints. So int width, int height. Okay. And there we go. So first, what we want to do on reshape also gets called when it's drawn first. Set the viewport. So the viewport is the window that is actually being rendered. So your GL window is memory space. It's frame buffer memory. Your viewport can be sort of anywhere within that window, but generally you always want that viewport to be the same size as your window, maybe same size as your screen. Say your screen is a wide aspect ratio screen like mine. You want that viewport to be the entire screen, not just a small section of it. So the way you do that is find the upper left hand corner and then find the lower right hand corner, and that's the size. So let's do that. Let's do GL viewport 0, 0 for the upper left hand corner, and then we'll want the width and height, but it's not width and height is ints, but you want GL size int. It's a different type. So GL size int cast width, and then we will copy that heights. Cool, so that now the viewport is the same size as your actual window, whether or not you resize it, whether or not it's a full screen, stuff like that. Now once we have the viewport set, we want to switch out of model view matrix mode to projection matrix mode. So model view matrix mode is what you're in by default. Model view matrix is the matrices and stuff that OpenGL has for you to draw to the screen. Projection mode is the camera. It's not the camera, it's the world, it's the scene. So the model, the matrices that you will be manipulating will control the entire scene, not the draw command matrices that get sent to the GPU. So let's do that. GL matrix mode, GL, Jesus, projection. Okay. So now we're in the projection mode. We can now manipulate the scene. And the first thing you want to do when you manipulate the scene is GL load identity, right? This runs the identity matrix function, which will reset the entire thing back down to 0. So you are now the center of the screen, the center of the scene, sorry, and everything's back to normal. Everything's right side up. Now we want to change our perspective. This is going to be glue perspective. And the glue perspective will set your field of view and also your near and far clipping planes. Near and far clipping planes are the planes that will, everything within them will be rendered. Anything beyond it or before it won't be. Think of it as render distance. If you have your clipping plane set behind you, that makes no sense. You're not seeing things behind you, so you're just wasting CPU cycles. Many applications have the clipping plane in front of the camera. That's what we'll do. We'll set it that way. So let's do field of view 60 degrees, 60 degree angle. Now here is an interesting thing for field of view. Field of view is not left and right field of view. Field of view is actually vertical field of view. That's what this function does. So the whole point of the reshape function is that it will calculate your horizontal field of view based on your vertical field of view when you reshape the window. So everything will stay the same size, and we will see that later when we run this finally. So 60 degrees field of view. We have to do width divided by height. That's for the aspect ratio. So it is GL float, lowercase, GL float width divided by GL float height. Okay, and now the near and far clipping planes. Let's do 1.0 for the near and 100 for the far. So anything between 1 unit and 100 units away from us will be rendered. Anything closer or further will not be rendered. Now, that's all done. We have the field of view reset after the window has been resized. So let's go right back to model view so we can start drawing again. So that is GL matrix mode GL model view. And we are done. And let us run the code. CD desktop OGL2 build. And as you can see, it's kind of strange. There doesn't seem to be anything being drawn. Why is this? That, my friends, is because the clipping plane is set at 1, not 0. Remember, we're drawing without moving. And when you draw something in OpenGL, you draw at the origin being 0, 0, 0. There's a few things we can do. We can go to the drawing routine and change where we draw the square. We can draw it further away from us, but that gets kind of tiresome, especially when you have many objects to draw. So the quicker way to do this is to do a GL translate. We ourselves will move to a new position in GL space, draw, as if that were 0, 0, run the GL identity matrix function, move back to the origin, and then display. So let's do that. So after the GL load identity function, we will do a GL translate F. And we will now translate to a new position in space. This is translate. There's no rotation, there's no stretching or anything like that. We're just facing the same direction and we're moving to a different space in GL space. So I want to move forward 5 units. So let's do 0.0f for the x, 0.0f for the y, and negative 5.0f for the z, because remember, forward is negative z, backward is positive z. It's just that's the way it be. So we move forward 5 spaces, 5 units, draw the square, run the identity matrix, so we come back to the center, and that's how it goes. So let's try running that instead. There it is, and as you can see, the square looks a little smaller than last time, and that's because we are actually drawing it 5 units away from us. So it's the same size, it's just further away. Now, check this out. If we move the screen smaller, the left, scale left and right, the square actually stays the correct size. And if we shrink the screen up and down, then the field of view changes, but the square still stays the correct size. So we now have a correctly working window. So if we made the entire thing full screen, it wouldn't be stretched. And that's it. That is this video, the simple reshape function. Next time we will be going over key presses. How do you capture key presses in OpenGL, and maybe we'll look at how to change the viewport a little bit. How do we use key presses to move around your scene and stuff. Maybe we could add a few more objects to draw and play around. And we are well on our way to mastering OpenGL 2.1 for the Raspberry Pi 4. See you next time.